So,
I'm gonna ask later.
okay, you guys.
Yes.
Is it gonna work? I think it's gonna work. I'm pretty sure that worked.
Then we can all meet tomorrow.
Touching dude. Okay, I think almost everybody is back. Oh, no, everybody is back. Okay. All right, so Nathan is going to be doing the model presentation here he has selected. Let him have at it.
Okay, so almost certainly this will have like a 3D component to it because the diagram that is used in the book is three-dimensional and it's very hard to understand without some more physical representation, so I will probably do that for you today. So this is the, and I will never pronounce it correctly, sorry, journal articles from 1991 do not tell you how to pronounce the creators' names here, but the Hoog, Jong, and Vries Model. And these terms are a bunch of like garbled, mouth-filling mess here. Product-driven educational simulation methodology. All it really means is this. The fundamentals of this model are that it is product-driven, so there were different categories of the models that we were studying in the G&V book. And product-driven means that the result of this methodology is a thing that the developers don't use, but that they give to the individuals who are the learners, and they use it themselves. So an easy example is like a textbook, but another might be a website. The individual drives and utilizes the product. It is very computer savvy because in order for this entire methodology to work, it relies on two things. The first, that there is a computer with the capacity for something called rapid prototyping, but all that really means is it can react to and respond to whatever the user is doing with it. Computers can do that, books cannot, for example. A web structure like the internet for adding adaptive elements. So if you create this entire learning system or product and the student uses it, but then that field changes 3 years from now, you want it to be connected to something like the internet, so that way it can be adapted over time. Also, here's a fun word, it's highly iterative. This is a fun term in software development that essentially, or engineering, that essentially means that it involves a rapid cycle of design, test, design, test, design. And the reason why this iterative statement is important is because this entire model hinges on the idea of Bam's spiral model. This is actually taken from software development. So this model is heavily inspired by the field of software engineering. And so what you've got here is essentially your system for slowly getting closer and closer through increasingly rapid iterations, the product that you desire. And so you start with the risk of what is occurring or what is at risk based on the success or failure of a particular product, in this case an app or a piece of software. Then you go through the plan phase, develop and review, and it begins to sound like IDDE. But the key to this spiral is the fact that it gets tighter. You should, like as an example, you spend 2 months going through this entire cycle, but then you spend 1 month, and then 2 weeks, and then 3 days. And by the end of it, you've got a product that's good enough to put on the market. Now we're going to take this concept and we're actually going to go a little meta with it, go one step up, because the model that I'm discussing is a methodology that includes this model 5 times. So the key to this model is that it is a spiral of spirals. And so the way that this works is you've got this pentagonal shape here with 5 different models, and each of those models is connected by these dotted lines, which represent the interdependency that these 5 models have. I'll describe what the models are in a second, but you'll see that, as an example, the spirals wrap around the axes between 2 particular models, meaning that that entire cycle that I was discussing here is happening with increasing tightness around 5 different connections between the way that the system is designed. Are we having fun yet? Because it gets a little more complicated than that. Here are the 5 models so we can help define them. The conceptual model is pretty straightforward. It's like Bloom's taxonomy. It's essentially understanding the cognitive domain of learning, such as data and reason. It's what you'd expect as you're going from just remembering to actually creating content. The operational model would be closer to our taxonomy for like developing skills and mastery. Then there are the 3 models of how it is developed and implemented. The instructional model, which means that we are analyzing how the development of this product satisfies what we as instructional designers would call good instruction. Then the learner model, so that it adequately observes students and collects useful data. This is something that also hinges on the computer being an adaptive and responsive device. And the interface model, which bridges the gap between simulation and learners through useful displays, controls, and responsivity. The key with this entire system is, if you've got 4 of them and not the 5th, it pretty much doesn't work. Because the massive advantages of a computer-based distributed product is that it is incredibly cost-effective and self-paced, meaning that it can be the most effective. But if you're missing one of these 5, it suddenly becomes almost unusable. I mean, imagine having the first 4, but the interface is incredibly confusing. You can have great instructional design with great data collection, but the student's not going to get any value from it. And you can play that simulation out with any of those other 5. So what that gets you at the end here, as a reminder, is this is the type of spirals that are going into what are called the partial product developments. I didn't use that term earlier. Each of these spirals right here in these 5 fields are called partial product developments. All 5 together is the full product development. And then in a similar way, you spiral through making sure that from an instructional sense, all of these things are achieved. So earlier, I was discussing the spiral from a software development perspective. They converted it into an instructional spiral, so that's nice. And then, as we get to the end here, this is the web structure. And so, as I was showing earlier, those 2 things together get you this, which gives you the global development of whatever your instructional product will be. And so, as an understanding of why is this useful, what on earth could it actually be used for, in any environment where these things are satisfied, this is probably the best methodology for you to take. So, in which an instructional product that is distributed via internet-based systems with a dynamic content and simulations, dynamic meaning that for each student it treats them differently. It responds to their needs. For individuals and self-paced learning for the sake of both knowledge or skill-based learning. And if you're like, okay, I still don't know what that means, here are some examples. These are products that take heavy advantage of using, not explicitly this model. I doubt that they were only using this model to develop them, but they would profit really well from it. A lot of people in here have heard me talk about Khan Academy, but they are an online learning software. Pearson Education does online modules and resources. Leapfrog creates digital games for children's learning. And there are driving schools, like online classes for driving instruction that help you using a very similar approach. And then Codecademy for those who are learning how to code. So those are the types of learning products that would benefit the most from this model. And these are the resources that I pulled from for the presentation today. And that is the Hoog, De Jong, and De Vries model for product-driven educational simulation methodology.
Thank you so much.
And I'm open to questions if anyone has them with what I know.
Really fast.
Very interesting. I have a question. We do the spiral. Do we do it 5 times in sequence or in parallel?
So this is where the 3D thing was going to come in. It would essentially, it's 5 spirals that are spiraling around each other. So you would have 5 spirals around the 5 axes, and they would close in on one another as your design loop gets smaller and smaller until theoretically you have the perfect product that responds to all of those needs. It's nice because if people kind of get what triangulation means, it means that you're focusing on the most important aspects first, and then worrying about the little details as you perfect and improve upon all of these things equally, not focusing too much on one at the expense of others from an optimization standpoint.
But it needs a lot of preparation, let me say.
Oh, it needs a lot.
Yes.
And that's why it
You can see
relies
that,
on
yes.
computing systems, because
Yeah.
you have to be able to collect intensive amounts of data and analyze it appropriately in a very timely format. And really only computers can do that for us.
Is that where the simulation piece comes in? Is it computer
Yes.
simulation?
When people see simulation, they start thinking like, virtual reality, all right. But no. All that simulation means is that it is anything that a computer presents to the participant or the viewer or the student that the student can interact with and that responds to the interaction. That's it. So if you've ever been on Blackboard and done a quiz, and the quiz says correct or incorrect and then gives you feedback, that's technically a simulation in terms of 1991 journal standards.
Will the production, will the production be used at the middle of the whole process?
Sure.
The finished product would be used when?
Oh, okay, I see. So the purpose of this methodology, which I didn't actually explicitly say, is to create the most efficient framework for developing the highest quality product to distribute to consumers. And so, while obviously the most straightforward instance is you have an idea, you begin using the model, through the model you create the product, and then you release it. The whole point of this is that it is highly iterative. So to your point, it is as easy as any other model with some strengths to implement once you already have a product, so that you can focus on the 5 axes that are important and then use that to improve upon it to create a better product. And that's really how software engineering works in any case. So I would see this being used in any of those cases. And to directly answer your question, once the product has passed the threshold as defined by the client, then you would release it. It will never be perfect, but this hopes to optimize the work you do by balancing your work across the axes.
And you said 1991?
The first time that this model was presented in the article, here's interactive computer simulation programs here. This was the first time that they started pushing away from what was called the waterfall model. Yeah, that was the earliest I could find.
Well, and Netscape wasn't even around yet.
Right.
Mosaic was
Right.
not around.
And then
There
this
were
is
computer-based
There were.
instructions.
right.
There
And that's
were.
why I was kind of finicky
Yeah.
with this term right here, web structure.
Yeah.
It doesn't mean the World Wide Web in their case when they first wrote about it. It really meant like a server, even a local server that just has the data that you need. And
Or way back then, it could have been something developed using, thinking back in the late 80s, hypercard.
Right.
Yeah.
Exactly, and
There were
so
lots
that it
of
was stored on a
things.
central database of some kind. So yeah.
Because certainly we were programming on, I won't even tell you how long what this was, on intranets really, so when I was in undergrad.
2 Bs.
Well, hey, I did have an Apple.
great.
One of those way back in the beginning. But no, not on those, but on mainframe computers. We did it all on like when I took computer programming courses, it wasn't on a
Right.
desktop, it was, well, when I was undergrad, I actually did do punch cards, yeah, for data analysis.
So
But actually programming was on a mainframe computer.
what's amazing is this already had some relative strengths before the internet existed. Now those strengths are infinitely more pronounced because of, as we were hearing earlier, big data and how companies are learning to use it really well. So this is where I get kind of excited about this, and I honestly kind of stumbled into this model. It was my 4th choice, as I was telling the professor, and it lines up almost as perfectly as possible with what I would want to do with my work. So
So
yeah,
fortunately,
the fates were good to
three
me.
other people beat you to your first 3.
Yeah, exactly. So fortunately, that ended up being the case. But yeah, there you go. That's the model.
Thank you so much. No, you're just doing this. Somebody else.
Mi question my miss.